Rabbi shrah li sadri wa yassir li amri wahlul uqtatam min lisani yafqahu qawli. My today's video is in continuation to my previous videos number 12 and 13. So please watch videos 12 and 13 before you watch this video. Okay, so we will do something that has already been done a little bit. So we will derive some equations of an ellipse before we jump on to binary star systems. Okay, let's draw an ellipse. This is the origin. This is the focus. The origin is at one of the focus. So this is the center of the ellipse, which is c distance apart from the focus, and this is the second focus, and this is 2c distance away from x-axis and 0 distance away from y-axis. And this point, the apogee, this is a plus c and 0, and this is a plus c distance away from the y-axis, where a is the semi-major axis. A is the semi-major axis of the ellipse. Okay, so let's first consider this point. Consider this point. Let's say the coordinates of these points is r cos theta. This angle is theta, and r sin theta. This is y-axis, this is x-axis. Okay, let's call this point A. In triangle F1A, F2, F1 is the focus 1, F2 is the focus 2, and A is the point on the ellipse with coordinates r cos theta and r sin theta. Applying the basic elliptical condition, or the condition of an ellipse, that is F1A distance plus AF2 distance should be equal to 2A, where A is the semi-major axis of the ellipse. So r plus square root of r cos theta minus 2c whole square plus r square sin square theta is equal to 2A. Okay, so r minus 2A whole square is equal to r cos theta minus 2c whole square plus r square sin square theta. R square minus 2AR plus 4a square is equal to r square cos square theta minus 4rc cos theta plus 4c square plus r square sin square theta. R square cancels with r square. So we are left with a square minus c square is equal to r a minus c cos theta. R a minus c cos theta is equal to a square minus c square. So r is equal to a square minus c square over a minus c cos theta, which is further equal to a square 1 minus c square over a square divided by a 1 minus c over a cos theta. Now from the above equation we see that eccentricity is equal to c over a. So r is equal to a 1 minus eccentricity square over 1 minus eccentricity cos of theta. Allahumma aghfirli, Allahumma hasibna hisaban yasira. Now from triangle F1 B F2, where B is this point at 90° with coordinates B 0, C0, CB, CB. We obtain C square plus B square plus C square plus B square is equal to 2A. 2 times C square plus B square, 2A, 2 cancels. So we have B square over A is equal to A 1 minus eccentricity square. Our ellipse is R is equal to H square over GM over 1 minus E cos of theta. If we select the constant of integration in my video 12 to be C is equal to minus pi by 2. So R is equal to R A square V A square over GM over 1 minus epsilon. where H is equal to RA VA at apogee, farthest distance, and theta is equal to 0. RA is equal to A plus C. From the above equation, we have VA square is equal to GM 1 minus E epsilon over A 1 plus epsilon, which gives us the velocity at apogee is equal to Gm over sigma major axis 1 minus eccentricity of 1 plus eccentricity square root. Now from my video 13, where I have proven the time period orbital of the planet, I have T is equal to 2 pi h cube over g square m square 1 plus 3 epsilon square over 2 plus 15 over 8 epsilon 4 plus 2n plus 1 1 divided by 2 to the power 2n 2n n epsilon 2n, with n is equal to 0 1 2 3 up to infinity. H cube is equal to RAVA cube is equal to A 1 plus E GM over A 1 minus E over 1 plus E cube. A cube 1 plus E cube GM over A to the power 3 by 2 1 minus E to the power 3 by 2 over 1 plus E to the power 3 by 2 is equal to A 3 by 2 GM 3 by 2 1 plus epsilon 3 by 2 1 minus epsilon 3 by 2, which is equal to A cube GM 3 by 2 1 minus epsilon square 3 by 2. Putting the value of h cube in the formula for orbital time period, I obtain T is equal to 2 pi a cube over g square m square. Gm whole to the power 3 by 2, 1 minus epsilon square 3 by 2, 1 plus 3 over 2 epsilon square plus 15 over 8 epsilon 4 plus 2n plus 1, 1 over 2 to the power 2n, 2n and epsilon 2n, where n is equal to 0, 1, 2, 3 up to infinity. So I obtain T is equal to 2 pi a cube over gm square root 1 minus eta square 3 by 2, and this comes out to be 1 minus eta square minus 3 by 2, where 1 minus eta square to the power minus 3 by 2 is equal to 1 plus 3 by 2 epsilon square plus 15 epsilon 4 over 8, 2n plus 1, 1 over 2 to the power 2n, 2n n epsilon 2n, n is equal to 0, 1, 2, 3, infinity. So we obtain, eventually we obtain 2 pi a to the power over Allah Maghfirli, Allah Maghfirli, Allah Maghfirli. So this formula looks familiar. Now the above formula is an approximation of the fact that the ratio of the mass of the planet with respect to the mass of the sun The sun is very small or negligible. Moreover, in binary stars system, there is no such thing as total semi major axis, but rather we have two semi major axis, that is A1 and A2. A1 is equal to RA1 plus RP1, where P is perigee, 1/2, and A2 is equal to RA2 plus RP2, where A is apogee and P is perigee, the closest and the farthest point of the planet from the other star or the sun. For binary star systems, we have two equations in Tahirian mechanics or Tahirian cosmology. That is d square r1 over d2 square plus gm2 over r2 square. R square is equal to v1 square cos square beta over r1. Beta is equal to beta 1 is equal to beta 2 in Tahirian cosmology. That d square r1 over dt square plus gm1 over r square is equal to v2 square cos square beta over r2. Beta is equal to beta 1 is equal to beta 2. That the above two equations must be written a bit differently highly significantly as below. For the first time in history. D square R1 over dt square plus gm2 over R1 square 1 plus R2 over R1 square is equal to V1 square cos square beta over R1. R is equal to R1 plus R2. D square R2 over dt square plus gm1 over R2 square 1 plus R1 over R2 whole square is equal to V2 square cos square. Because we are talking about binary systems, and in binary systems, two stars circle around each other in elliptical orbits or circular or whatever other orbit is. T is equal to T1 is equal to T2. Theta is equal to theta 1 is equal to theta 2. Now we already know that in binary star systems, M2 M1 is equal to R1 over R2, where M is equal to M plus M2. I will not prove these identities here. I will make another separate video on the proofs of all these and other identities that eyes have not yet seen in a entirely elegant, splendid and magnificent manner. Pretty T1 is equal to 1 plus M1 over M2. T2 is equal to 1 plus M2 over M1. G square R1 over dt square plus gm2 over R1 square T1 square is equal to V1 square cos square beta over R1. So the above two equations become, and the second one is d square R1 R2 over D2 square plus G1 GM1 over R2 square D2 square is equal to V2 square cos square beta over R2. should be the T1 square or T2 square terms in the result. So finally we obtain T1 is equal to 2 pi A1 to the power 3 by 2 T1 divided by square root of GM2 is equal to 2 pi A to the power 3 by 2 1 plus M1 over M2 divided by GM2. We can also write it like this. T is equal to 2 pi 1 plus M1 over M2 GM2 A1 A2 T1. So similarly T2 is equal to 2 pi 1 plus M2 over M1 divided by GM1 square root A2 to the power 3 by 2. So these two are the compatibility equations for orbital time period of binary stars. In my previous video, Subhanallah wa bihamdihi, Subhanallahil Azim wa bihamdihi, Astaghfirullah. Number 12, I used the combination d square r over dt square plus gm over r square is equal to v square cos square beta over r, and h is equal to rv cos beta. To derive the formula for orbital period, orbital radius, but under binary star systems, of which the universe is more than 50% made up of the same formula change as below. D square R1 dt square plus gm2 over d1 square r1 square equal to v1 square cos square beta over r1 and h1 is equal to r1 v1 cos beta and d square r2 over dt square plus gm1 over d2 square r2 square is equal to v2 square cos square beta over r1 r2 and h2 is equal to r2 v2 cos beta. Beta is equal to beta 1 is equal to beta 2. Okay, now let T1 is equal to T2. 2 pi A1 3 by 2 1 plus M1 over M2 divided by GM2 square root is equal to 2 pi 1 plus M2 over M1 A2 3 by 2 divided by GM1 square root. These two terms cancel out. So we are left with A1 to the power 3 by 2 1 plus M1 over M2 divided by M2 square root is equal to 1 plus M2 over M1 A2 3 by 2 divided by M1 square root. Bismillahirrahmanirrahim. Kul huwallahu ahad. Allahu samad. Lam yalid walam yulad walam yakul lahu kufuwan ahad. Now I will prove the general formula of Tahirian cosmology or binary star systems as below. T1 is equal to 2 pi 1 plus m1 over m2 a1 3 to the power 2 multiplying the numerator and the denominator by 1 plus m1 over m2 divided by 1 plus m1 over m2 square root. I obtain 2 pi 1 plus m1 over m2 3 by 2 a1 3 by 2 divided by g m1 plus m2 which is further equal to 2 pi a1 1 plus m1 over m2 3 by 2 divided by gm1 plus m2. Now m1 over m2 is equal to a2 over a1. a1 and a2 are the semi-major axis of the binary star systems. So the above becomes 2 pi a1 1 plus a2 over a1 3 by 2 divided by g m1 plus m2. So this becomes 2 pi a3 by 2 over g m1 plus m2 k root, which is further equal to 2 pi a cube divided by gm, where sum of the semi-major axis A is equal to A1 plus A2 and M sum of the masses is equal to M1 plus M2. Okay, so finally we have the formula. T is equal to 2 pi cube of the sum of the semi-major axis divided by G times the sum of the mass, where T is equal to T1 plus T2. T is equal to T1 is equal to T2. Subhanallah wa bihamdihi, Subhanallahil Azim wa bihamdihi, Astaghfirullah. Please like, subscribe, and share my video with others so that they can benefit from it as well. Thanks for watching.